Let's go on to shifting the location of a moment by changing certain variables of a couple. As you may remember from week 2, a couple can produce moment or torque. Let's consider the following beams and find the reaction for each of the examples. First, a beam with a couple where its leftmost force is 3 units from the left end of the beam point A. When taking the moments about A, you'll have your sign convention as well as the contributing forces to the moment of A, which in this example is By. This will give you M about A equals 0, as the system is in equilibrium and we are assuming counterclockwise is positive, which means clockwise is negative. 0 in equilibrium will equal negative 20. Before we continue the rest of the equation, notice how it's negative 20 because it's clockwise. So it's negative 20 times 3 plus positive 20, as it is in the counterclockwise direction, times 4 plus By times 10. We then get a final answer of By equals negative 2. Second, let's look at a beam exactly the same as before, but with the leftmost force of the couple, a distance A, from the left end of the beam, point A. First, let's recall the final answer from problem 1, which was By equals negative 2. Taking the moments about A, we get M about A equals to negative 20 times A plus 20 times A plus 1 plus By times 10. Solving for By, we get By equals negative 2. Third, let's look at a beam exactly the same as before, but with a moment of 20 applied at a distance B from the left end of the beam, point A. First, let's recall the final answers from problems 1 and 2. The answers for both problems were By equals negative 2. Taking the moments about A, we get M about A equals to 20 plus By times 10. As a final answer, we get By equals negative 2. Notice how each of the reactions at B for each of the problems are exactly the same. We conclude that the location at which a moment or couple is applied to a beam does not affect its reactions.